So as you can see, example number 5 is a little bit different. It's asking for the limit as x approaches plus infinity and minus infinity, not a specific number like 3 or 2 or 4. They want us to know what happens as x goes to infinity, meaning what happens if x gets bigger and bigger. And to do this problem, I'm going to use a table. So again, using the calculator, I can do this very quickly. So first of all, I'm going to type in the function f of x that was in the problem into my calculator. So in this case, the function f of x is 1 over x minus 2 plus 3. So I take it to the calculator and just make sure you don't forget to put the parentheses around x minus 2. So once that's done, we're going to go second and then table. That puts us in the table. If you have numbers in there, don't worry about it. You can write on top of them. It doesn't matter. So I'm going to type in the numbers in the first table, which are 5, 10, 100, and so on and so forth. And the thing that I want you to be noticing right now is what do the blue numbers look like? And as you can see, the blue numbers all look like 3.3, 3.1, 3.01, 3.001. The bigger the number, as a matter of fact, the closer I am to 3. So if I put something ridiculously large, like something random but really, really big, because x is going to infinity, I'm allowed to do that. I can pick any x that I want as long as I want it to be as big as I want it to be. And you'll notice that eventually the number turns out to be 3. Now, if I do the same thing again, but with the same numbers, but with the negative side, so if I try to plug in the negative values, so let me go back up there and plug in -5 instead, and -10 instead, and so on and so forth, what do you notice again? So again, I want you to be looking at those blue numbers and kind of thinking about the pattern. What does the pattern look like on those numbers? So if I put something really, really, massive but negative, what does the number look like? Again, you'll notice that the numbers are 2.8, 2.91, 99, 99 again, and so on. Eventually, they turn out to be 3. So regardless of whether we are in the first table or the second table, the numbers are turning to look like a 3 at the end. So what does that mean? That means that this side of the table tells me that as the x goes more and more to the right, so as x gets larger and larger to the positive side, the numbers that I'm seeing at the end are all looking like a 3, right? 3.001 and so on and so forth. And similarly, the second table tells me that as my numbers get more and more towards the left of the graph, so as they go towards the negative infinity, as the x's approach negative infinity on this function f of x, the numbers on the y will all be relatively close to 3. So the more left you go, the closer to 3 you are. To illustrate, let's take a look again at the graph. So this is the graph of the function in this problem. Let me make this bigger. And what I want you to know is, and notice, is what's going to happen as I go closer and closer to the left side, and what happens as I go closer and closer to the right side. What's going on with my y coordinates? So like, for example, let me trace, for instance, -10. You'll see when I trace -10, the y is roughly speaking 2.911. And if I keep clicking more to the right, you'll notice that the numbers will stabilize, sort of, roughly speaking, around 3. They will never ever reach 3. I have to go all the way to infinity to get to 3, but eventually these numbers are becoming sort of stable. They are all looking like a 3. If you notice, the line is kind of a horizontal, and it's right about level 3. Same thing would happen if I go to the right side. So if I trace, for example, 10, well, it's not going to let me do that because 10 is not visible on my screen. Let me change it. Let me fix it. Let me trace, let's say 2, and go from there. So if I trace 2, the y coordinate does not exist, but if I go more and more to the right, you'll notice that as the numbers tend to get larger and larger over here on the x, the y coordinates will tend to get closer and closer to 3. So we can keep doing that for a while, and there you go. The more you walk to the right, so the bigger the x is, the more the y is looking like a 3. So obviously it's not exactly 3, but all those numbers right there on that blue line, they all look pretty much the same. They're all kind of forming almost a horizontal line that is about level 3 again. That's what the limit in the table is telling us.